Hello all, we are here presenting the assignment 5 for our mechanical sessional. The group members are me, Kaushal Paradia, 20 ME 3FP09, Druhin Abrol, 20 ME 3FP33, Mohit S, 20 MF 10023. For this assignment, the flow of the presentation will be as follows. Problem statement, 4-bar mechanism, Grashof criterion, degree of freedom, displacement analysis, assembly of the garage door, geometry of the mechanism, simulation of CAD model. Problem statement. Synthesize and make a simulation for a garage door mechanism that does not have a prismatic higher kinematic pair and occupies less space to remain open. Over to Mohit.
So moving on to the 4-bar mechanism, as you can see, the crank is a part of the 4-bar mechanism which can rotate completely all 360 degrees, and rocker is the part which can only oscillate to and fro and cannot make complete oscillation. And the frame is that part of the 4-bar mechanism which is fixed. Moving on to the Grashof criterion, we have displayed 4 cases here. In the first case, there are 2 cranks which can make complete rotation, that is the 360-degree rotations, and the crank rocker mechanism is a 4-bar mechanism in which the minimum length can make complete oscillation, and the other link that you can see, that is P, can only oscillate to and fro, and it is a rocker. And moving on to the next case, here both of the links are rockers and they cannot make complete oscillation, they can just oscillate to and fro. And the parallelogram linkage is a special geometry linkage in which both the rods are of equal length and they can make complete oscillations. And here comes the calculation of the degree of freedom of the 4-bar mechanism. Here we can see that there are 4 links and there are 4 joins. And among the 4 links, one is ground. So that's why we have subtracted 1 in the degree of freedom calculation in the first term, which involves the links, and 1 is subtracted, which indicates ground, which does not provide any degree of freedom. Then we have subtracted the number of joins multiplied by 2 because these are lower pairs, and because of which and each one of them subtracts 2 degree of freedom, and hence following this calculation we get a degree of freedom of 1 in the 4-bar mechanism. Moving on.
Displacement analysis explains the overall displacement of the mechanism. By this, we can explain and get the location of each and every point in this whole mechanism. As Mohit mentioned before, thus the degree of freedom of this mechanism is 1. This means that using just one parameter, we can define the displacement or the location of any other point in this mechanism. Here we have here we can see that in the equations given on the right side, BD is a parameter of theta2. So let's take the case where every of this angle or the length is defined using the parameter as theta2. So BD is the parameter of theta2, as we can rightly see. Gamma is again a parameter of theta2, and a BD, which is a parameter of theta2. BD here we find using by applying cosine rule in the triangle ABD. Gamma is found applying the cosine rule again in the triangle BCD. Theta3, which is the slope of line BC, is found using by the following formula, where it is a parameter of theta2, and gamma, which is a parameter of theta2. Theta4, which is the slope of the line DC, is again a parameter of theta2, and gamma, which is altogether a parameter of theta2. Hence, By summing up all these four equations, we can see that all these four equations are governed by just one parameter, which is theta2. Hence, proving that the degree of freedom of this mechanism is 1. Moving on with Druhin explaining the overall simulation of this mechanism.
So, hello everyone. I will now proceed with the geometric design as well as the simulation. So, in SolidWorks, I've created a basic 4-bar linkage, and here you can see it is a 4-bar mechanism and it is a double crank mechanism since both of them can rotate full 360 degrees. So this is actually a partial view of the garage door I made. And now we can see the entire garage door. So let me show you how it works. This is how it is extending and contracting. So the issue with traditional garage doors that we have seen that usually rolls up or slides on rails when it contracts or extend is that those rails get damaged over time because these garages are like they're mostly outdoors and dust and all settles in them and it wears down over time. So the best thing about a mechanism with no prismatic joint is that it will basically last the test of time and it will last longer than any other mechanism that involves the garage door sliding on rails. Right. So let's look at the innovation that we have here. So the main innovation that we have thought of is adding a spring to these linkages that I have pointed out with this red arrow. So how that would benefit is it would basically help in the manual use of garage door. So we know not all garages are automatically operated and most of the doors are still manually operated. So this would basically help in keeping the door closed when it is meant to be shut, and when it is open, it will make sure that the door just won't fall out because of its own weight. In SolidWorks, I can show you how it exactly works. So right now we can see since this angle is obtuse, we can see this has the tendency to remain shut if a spring is attached between these two linkages. And after this point, this angle gets flipped. So beyond this point, this mechanism has a tendency to remain open. So this is how the mechanism will kind of keep itself in equilibrium and stay open when it is desired and stay closed when it is desired. So that's it for today, and have a nice day.